Okay, so we've got two people who have not been introduced. I'm going to ask the famous Don Bartusiak to introduce himself, and then Mark Hammer.
Howdy, everybody. Don Bartusiak. I'm the president of Collaborative Systems Integration, CSI for short. And you've heard my track record as former chief engineer for process control with ExxonMobil. That's enough for now.
Good afternoon. Mark Hammer, Yokogawa, OPA product management, and been involved with the development for the last couple of years in the test bed and all that. So kind of like Tito and Dave here, I've had a lot of aha moments that this is going to work.
Very good. So I'm going to open it up for questions if anybody has one now. Go ahead. Oh, you're just raising your hand. You're just raising the microphone. Tim, you should ask a question.
Well, you don't want me asking questions.
All right up here. Miss.
Who's got the question?
No, Mike Williams. He didn't raise his hand.
Mike Williams from ARC. I'm butchering your name, Amar from Aramco. You really got me going with your amine scrubber AI application. Closed loop AI, big value proposition. Where are you at right now at this point in time with that pilot, as far as realization that it's truly can do closed loop with AI? Where are you?
So yeah, we're still at the pilot stage. We're still
How long have you been running this?
like more than few months. More than few
Okay,
months.
it's still early days then.
Still running.
Stay the course.
And we're piloting, so we are evaluating it. But yeah, we will give feedback as soon as we have it.
Stay the course.
Yeah, we'll try to.
Other questions?
This is Siva from Dow Chemicals. My question is to Mr. Timothy Triplett. In your test bed case, you talked about the control system. Are you also planning to implement safety instrumented system as part of it, or you are planning only basic process control system?
See if I understand the question. Would you ask the question once again? I'm not sure I understood.
Sure. We understand you are talking about a test bed case.
Mm-hmm.
But in this case, have you considered scenarios to implement safety instrumented system as well or not?
Oh, okay. A safety instrumented
system
yeah. Online. Not in this particular research initiative, but it's recognized that there will need to be independent safety instrumented systems to augment that are independent, but they could use a similar OPA approach, I suppose, or they could be just anything all the way down to just an analog system, something as simple as a temperature switch that initiates some action. There are a lot of different approaches in the nuclear industry, and the idea of redundancy and diverse systems is important. I mean, that adds more and more layers of security, reliability, and safety to the system. But you could build a safety instrumented system within an OPA approach. But I wouldn't want to use exactly the same hardware and exactly the same software.
No, I mean,
Okay. Next question? Oh, you're in trouble now.
All right. So I'm David DeBerry with ExxonMobil. My question to the panelists, as we've talked about artificial intelligence and digital twins, machine learning, obviously the goal is to some point get to more autonomous operations by using these tools. Can you guys comment on what are their prerequisite components, features, functionalities that are going to be needed in the infrastructure to support this advanced software capability?
Who wants to go first? Nobody wants to go first.
Nobody wants to take that one.
one.
Well, I guess that's one of the things I get excited about OPA on, is that provides that data model. And it's a rich data model that we can use to add all this stuff in. So the integration of all these tools becomes consistent across, whether it's the pick your APC model, pick your AI model. Now you have a data set that's common and strong that everybody can use. And so that's where I really like that OPA open technology to allow that data to flow up easily into all of these different models without having to go through various gateways and conversions and this, that, and the other.
Yeah, Dave, I'll comment. You can't ignore the fundamentals. Okay, your sensors got to be accurate and reliable. Okay, your analyzers, you can't be dependent on the vagaries of your sampling system. You got to do the blocking and tackling, the fundamentals right, and you really need to resist the temptation to paper over instrumentation problems with math. Solve the root cause problems. Make sure your talent has the proper skills and resources. I mean, that's the blocking and tackling fundamentals in this journey towards autonomy.
So I'll comment maybe more from the infrastructure side. So if there's anything that makes the news these days, it seems to be how much compute we're using to develop these models. And I think, what was it, Tuesday, we all were laughing about the t-shirt size of the ACP and how big it was. The systems that we're deploying, or the OPA systems that we're deploying today, have a significant more horsepower than what we've seen in the market in the past, both from a processing perspective, a memory perspective, a storage perspective, and a networking capability. To the point, the ACP that's at Baton Rouge has 100 gigs to each of the hosts. And so, you've got the foundation set to be able to do some of these advanced things at high speeds that may be required to do some of the really fancy things that we want to try to do. And so, again, this provides the pathway to begin to explore and implement if there's value and there's a reason to do so. It provides you that horsepower that maybe historically we haven't had inside the actual system. You may have side-strapped it, but then you're trading off data availability for compute. So yeah, it's an exciting time, I think, when it comes to AI and these types of systems.
Anybody get the comments? Okay.
Well, maybe just chiming in on the question. In Namur, there is actually it was WIB who worked together on Namur to create a matrix that actually shows you all the steps and all the intermediate things you have to do to get from level 3 to 4 for different workflows and swim lanes, etc. So there is I'm not gonna commercialize this for being a Namur member, but if you are a Namur member, it's there, and it's certainly something to look at. So, and it's pretty complete. So that's been checked by a pretty big community. So I would like to, take the opportunity to make everyone aware of that.
Okay, we have another question? Okay. I'll get you next, Mark.
Jeremy Meeks with Chevron. I've got a question for Tito. I appreciate your willingness to take on this new technology. It sounds like you're comfortable with it now. Recognizing that it sounds like you've been on this since kind of the beginning. You said for like 3 years. I guess my question would be, have any of your counterparts kind of cross-trained on this system? How long did it take them to get up to speed? And if not, how steep do you think that learning curve would be?
So I wasn't on it in the beginning. I got on the project about 2 years ago. So they were already working on the concept and everything else. I am tasked to build out a training plan for my counterparts. And so I don't think it's going to take long for someone to pick it up. I mean, I picked it up you know, in a fair amount of time. I don't think, see how I want to word this. I don't think it's going to take long, because when I first started learning what products we're going to use, I just started Googling. And from Googling, I started seeing, free training, and I just started learning myself. So I don't think it's going to take that long, but everybody's different. Make sense?
Yeah, it does.
Okay.
Thanks, Tito.
Let me follow up on that. Do you think a younger engineer would have a quicker up or pickup time? I don't mean to insult you or anything,
I know I got the gray right here. My dad did that. I can't do nothing about that. I don't know. I think everybody's different. I mean, if I see something one or two times, I pick it up. This younger generation, everybody got their story about the younger generation. So, honestly, and I don't think it'll be hard to pick up, because even right now, I don't know everything, but, and understand the system is not perfect, but if from the past couple of problems we had maybe a month or so ago, if I was able to fix it without having to call, Dave DeBari or David Hedge or even Yokogawa, I'm sure they'll be able to pick it up. I don't think it'll be that hard. Once you line it out, I think they'll pick it up easy.
So I want to add on to that one. So it's interesting to watch kind of the evolutions in the control systems of the world. So virtualization being kind of a 2000 to 2010 kind of thing. That was that's when I was in school. That was a hot thing, being taught in universities around the globe as folks came out. So they had that skill set coming into the workforce. What we watch in A&M and other universities, the technologies that the kids are learning is changing. It's very cloud-centric. Instead of, the VMware by Broadcom, it's now the AWS microservice kind of mentality. They're doing different things. So, as we look at, what do these systems look like? What are the technologies in them? They are somewhat aligned to what, folks are learning or the kids are learning in school. Does that accelerate the ability to adopt these types of technologies? It may. Your engineers may be able to pick it up faster. But I know, for the Yokogawa staff, they are relatively earlier in their career. They haven't maybe seen, the heritage systems or even what your Centum VP system necessarily, but they understand the technologies that are part of this, and they know how to go and Google. Right. They know how to go and learn about the technology, how to stitch it together. So, it's interesting to see, Tito's a great example of someone who's been in the industry for so long, learning something new. And then you have a new generation that's going to come in that maybe already has these types of experiences that may pick this up faster. We have yet to see that, though, because we're still early days.
Anybody else? Okay, question? Julie?
Hi, Julie Smith with DuPont. Glad to hear about all the great success of the Lighthouse and how you've accepted it, especially, Tito, congratulations. But I've been around manufacturing a long time, and I have to believe that there was some resistance somewhere in the plant along the way. Can you tell us a little bit about that? Where did you run into resistance, and how did you overcome it?
I mean, which way? It was resistance. People, like I said, some people don't like change. But when the plant manager, she was the one that the plant manager at the time, she was the one that asked me to, come into control systems back in 2010. So, prior to that, I was, in operations, then Emmett before that, which is IT. She came to me and she asked me, she was like, well, Tito, should we be doing this or not? And I said, yeah. I said, it's going to be a good thing. It's like a baby, you got to hold him and guide him. And once you guide him, he's going to be up and running. Yeah, that's what I believe. That was one of the resistance, and some of the other folks that deals with the other technology. They was like, nah, it ain't gonna run. No, it's gonna run. If I'm here, we gonna do this. So, you know, it came from all different places.
I think the interesting thing from a resistance standpoint is customer adoption of this new technology. What do we do with it? How do we support it? How do we, you know, all of that stuff, right? You've gone through it with the A&M on what is this stuff, right, from the traditional skill set. And we're hoping from a supplier standpoint that now that Lighthouse is out there, we've proven it worked, we've proven we can train people and get people to run that more users will start adopting that and get over this resistance hump. It's there, it's really cool, and a lot of us that have been in the industry for a number of years, we do get that change. It's like, wow, this is just really cool. And the flexibility, and when we start adding all this compute and you start saying, I could run, you know, 100 MVCs, you know, on this platform. Those, and we have to rethink how we do this and reimagine the capabilities of what we can do. So I still think there's some resistance in the industry. I still think users are thinking about it. I think if you look at ARC this week, there's a lot of openness around it, shall I say. And so we're hoping that we get over that resistance hump.
A quick follow-up on that one. What did you do with the operators to get, did the HMI change any, or did it look the same? Did you change? Because the moment you change your graphics, they have a cow.
Good. You're your operator, man.
Well, they chose to have their HMI built the same way as the old HMI. Mm-hmm. So it was fairly quick and easy. I think they did a week of training on the actual new system, but as far as my HMI standpoint, it was you know, it was no different. It was easy. They just need to learn how to get to the different pages.
Right. And I think the one thing, if I can expand on that a little bit, Tito, is that from an operations standpoint, the goal was not to change their interface, that all of the technology is hidden behind it, right? So that the operator goes, oh, I have to change a set point. I have to get this alarm. That didn't change. The technology behind it's changed. From an operations standpoint, the real goal was, oh, it's just like a DCS, right?
Yeah, because it is a DCS, right?
It is a DCS.
So, question for Amar. I hope I said that right. So, your pilot study with the reinforcement learning application and the ambient temperature control, what kind of challenges have you seen in that? It could be both technical or non-technical.
For the implementation, so we face similar challenges to adopting new technologies, which is, I think, the same everywhere, right? When you try to implement anything new, you face resistance from the engineer, from the operator and engineering. In that specific case, we had to give the operator some kind of leeway. So he had the option to turn it on and off. And we gave him that confidence, like you can turn it on and off whenever you don't feel comfortable. But what we have seen, like, interesting is that as time goes, they have become more comfortable and relying on the system once they have seen the results. So, of course, yeah, similar to APC and any technologies that we implement. Operator, you have to take their buy-in. They have to trust the system and know how to utilize it. Initially, we were worried that they will not accept it, but they are willing to test and see. So, does that answer the question, or you're looking for?
Sorry.
So, what about that problem made you choose the reinforcement learning approach rather than something more traditional?
We do have something traditional, like we can use the ARC, right, Advanced Regularity Control, but we wanted use of RL because it's more adaptive, right? Because you know, reinforcement learning has the continuous learning capabilities, able to do nonlinear also. So we wanted to test that because we believe there is potential, but how does it work and how? That's why we wanted to pilot this. And of course, we didn't do this ourselves. We also worked with our vendors, DCS vendors, to make this happen.
And then one last question for all of the panelists. What do you think about the adoption of reinforcement learning in the industry over the next few years?
Well, I guess the one thing that I really thought about in preparing for this panel is it's not like the AI techniques are going to completely replace our existing algorithmic methods for control. I mean, what autonomy is going to look like, and I believe at the end of the day, is a mix of the technologies. And I think Amar explained it very, very well on what the real world is going to look like at the end of the day. So, are we going to apply reinforcement learning everywhere that we have a PID today? No, I don't think so. But I think where you've got, problematic, whether you do have nonlinearities where you could approach it with gain scheduling with PID, I think replacement learning will take over that use case. If you've got chronic problems with sticky valves and you can't afford to take the plant down to fix that valve, then something like a reinforcement learning supplement to the algorithmic methods. Again, Amar had a pretty, that three-step chart that he had, I think depicted it pretty well. I mean, we're going to see the machine learning technologies become into the mainstream of our modeling tools. I think we're going to see the Gen I technologies doing coding work, the fundamentals of engineering work, voice-based operator interfaces. That's what we're going to see at the end of the day. And I think the open platforms, the standards-based open platforms will enable us to innovate faster than we have historically.
Anyone else want to comment? I'll comment, just because I can. I got a mic. I think to Don's point, we have to stop looking at what's the new technology to replace everything, but remember that we have a toolkit available to us, and it's horses for courses, right? It may not make sense to do all the work to put into an AI model when I can just use a PID and have a tuner on top of it, right? I've told a different audience, but I said, look, if you can do it with a camshaft and some sensors, do it with a camshaft and some sensors, right? It's proven technology, it works, and if it works good enough, that's great. But if you've got a problem that you're having trouble solving, and you're looking for that next 1% of value, whether it be quality or cost or whatever it might be, then look for a technology that's going to address that 1%. Any other questions? This is your chance. Come on, guys.
All right, so I want to ask a question of the audience. How many of you are looking to deploy AI into your control system today? Okay. All right.
Go ahead, Mark.
So for some of you that have been through a traditional DCS migration, how did the transition from the traditional to the open compare to a traditional upgrade?
Well, that's a great question.
No, I've never done one.
So I've been through OPM's own process migrations, and we've recently did an upgrade on the OPA system. And, I think Whit explained it earlier this morning, to take a couple of weeks to plan, and then you have to plan around an outage, and then it takes, a few days to do it, versus using the Ansible, clicking the button, and if I want to, I can do all of them at once, but me, as I choose, I do a certain amount at a time, because, you could still, cause a lot of problem with a whole lot of data, moving back and forth, but that's what I choose to do. So for me to go from one system and doing an upgrade versus this one, I choose this one all day long, because it doesn't take long, and then I can schedule around a good time where they're doing a grade switch or a cat change or, something to that effect, where they're not going to be down but for a few hours, you know, I can take that time and do my upgrade, and it's, you know, we're still moving. So, that's
Mark, I'll have a go at that. So we actually used to explain the concepts to our management. We used to draw these charts about what DCS replacement projects used to look like. You just cruise along for a time, you have big cost spike for your replacement and upgrade project. Cruise along for another 20 years, big spike. Pattern continues. What we're seeing with the movement now towards, you know, modularity, standards-based, component-level interoperability, I think our control systems upgrades in the future are going to look kind of where our IT upgrades have gone to today. I mean, if you remember in the day, if you're working in a big company, like an IT replatforming change, massive disruption. I mean, everybody was involved, right, Dave? Today, we don't even see it. It's in the background, okay? Like one day you got to go in and replace your laptop, and you don't even see what goes on behind the scenes. And now with, you know, if you don't have to replace your I/O, you leave you leave your field terminations, and that I/O is still generating an OPAS conformance signal. You can incrementally replace and upgrade the compute layer, the networking, add your software. I think future control system upgrade projects are going to be much less costly and operationally disruptive than looking backward.
Okay. Well, we got 7 minutes if you want to use it. If you want to leave a little early, we can do that too. Oh. Okay, it's this guy that's holding us up. I'm just telling you.
I'm always holding you up. Sorry. I apologize ahead of time. I was kind of thrown by the word autonomous because you know, that means to me like automated guided vehicles and robots running around with less human supervision. So I'd be glad to hear what autonomous means to them. Does it mean like sort of the same thing, like operations are kind of able to go with not as much human supervision? I think autonomous might be the wrong word. But what does it mean to you, and you know, whatever thoughts come to mind?
Sure. Okay, I'll take this one. Autonomous, if you can imagine a small power plant in Haiti or Ghana, someplace, and it's running itself, and it doesn't have an operator monitoring it, supervising it, but rather it's handling more of the things that an operator would use his judgment to do, that is built into the system. I can see in the future, I mean, I don't know how far off this is, it's probably closer than I think it is, but where what does an operator add to the operation of a plant? He has an understanding of the business objective of the plant. He has an understanding of, well, if we change this or we go down, what are the impact? This little power plant is running a hospital with active surgeries going on, or it's powering a command and control system that is critical to potential conflict that is underway. And the operator knows, hey, the bombs are falling and we're in the middle of a war, and I've got something that's sort of questionable. Maybe I should shut down, but no, not right now. I will take the risk and go ahead and run through it. Or I'm getting sensory input that a normal control system wouldn't understand. Like the ground is rumbling and shaking. I hear a high-pitched whistle going off in the distance. What does an operator? What does he add to the operational capabilities of a system? And I can see that all of that's being integrated in. Artificial intelligence, if you want to take it to the cars and such. I drove from Texas to Florida, 2-day trip, 17, 18, 19 hours, and basically I didn't touch the steering wheel, the pedals of my car, and it did all the overtaking of other cars and taking exits and interchanges and everything except it didn't know exactly where I wanted to park. So when it got there, I took over and I said, okay, I want to park in that parking spot. I think that having the open systems enables that level of technology when it comes to be integrated. When is it going to be? 1 year, 5 year, 20 years? I would guess 20 years it will be there for sure. 10 years, maybe 5 years, who knows? But we're laying the foundation to not box ourselves in. We have an open road in front of us, and we're not constrained. We're sort of why A&M has got 70,000 students and growing, and they're just going to have to artificially, I think, stop at some point. There is no physical constraint around A&M. It's in the middle of nowhere. So there's no mountain, there's no river, there's no anything, no other buildings or other facilities that says, oh, we can't expand and put another building there. It's like they've got 2,400 acres in one of their research campuses there in the College Station area. It used to be an airfield for military training. So it's just, we don't want to be constrained. And I think that's where open process automation takes us.
Yeah, Jim, I'll give you another take on it. I mean, a strict definition is reduce need for manual attention to run the unit. But what I think is going to happen over time, the autonomous system is going to really handle routine operations, including startups and shutdowns. But you're still going to need people to handle those edge cases, those abnormal conditions. So I think what's going to happen over time is, our operators are going to, we've used the pilot analogy over the years, but I think we're going to have to provide more like simulation-based training to the operators to handle those, low frequency, high consequence events that you just simply can't afford all of the investment required to handle with computing systems. And I think and it's not going to be an overnight thing. This is going to be a gradual trend over time.
Okay. Well, with that, I'd like to thank our panelists and thank you for attending.